Hello, everybody, and good morning, and welcome to the DPUK ECR morning. It's really nice to see you all, and for some of you, it's the first time I've seen you in person rather than on a screen. So thank you very much. And I also want to thank the Alzheimer's Society, who has sponsored this morning ECR event. And Cherie over there can answer any questions about Alzheimer's Society. And they also have a stand outside next to ARUK. So thank you very much. So we have a packed morning this morning. I'm going to, yes, there we go. Hopefully that my slides go on nicely. And we hopefully have a lot of interesting presentations really that will feed into not only your current work, but also your career as an early career researcher. I just want to also say over the next 2 days, please do come and pin me down and ask me any questions about DPUK. Can only present on a very little bit here, but I'll be around and I'm always happy to answer questions, to log into the portal, to show you what it looks like. So please do come and contact me. So I'm going to move on, and I'm going to just open it with telling you a little bit about DPUK. Some of you are very familiar with DPUK, but for those of you who are not, hopefully this will give you a snapshot of what we're about. So this is the program. You should have a copy of this inside the folder of your annual report and your data portal reports. If you open it up, inside there is the program. And I just really hope you have a great morning and a great conference. So this is the DPUK landing page for the data portal, where we like to think of ourselves as a one-stop shop, really, to access secondary data sets for dementias research. Now, a lot of our cohorts are collected for many other purposes, whether that is cardiovascular disease, cancer, Huntington's, perhaps it's a birth cohort or a healthy population cohort. But all of these resources, so that's over 63 to 65 cohorts across 3.5 million individuals, can be repurposed for dementias research. So for some of these people that are going into the clinic at the age of 70 to 80 with perhaps some memory complaints or cognitive change, we're able to then look back in their history and understand, well, what were they doing in 1950? What were they doing in 1960? So the value of legacy cohorts cannot be underestimated for dementias research. So on this landing page, you can see where you can identify, access, and analyze cohorts of interest. If you have a question that you would like to have additional data sets besides your own for, then this is really the place to come. And I want to emphasize that your projects that you submit the proposals for, you can bring in your own data sets. So if you've collected a data set in your current academic situation and you'd like to validate that alongside a DPUK cohort, please do submit your proposal and bring in your data for working alongside the DPUK cohorts. So these are the tools that we provide for researchers to identify cohorts of interest. We have the top level cohort matrix. We have the cohort directory, where you can click into the cohort of interest and see what they've collected across how many waves. So if you're interested in depression, you can look at, for example, in ELSA, that they've used the CESD score across multiple waves. So these tools inform the application that you go on to submit through the application process. We also have a biosample matrix, where you can see which of our cohorts have collected biosamples and how to access these off the portal. We have an imaging matrix for those of you who work with imaging data, which is not only derived, but raw image data, fMRI, whether it's MEG, PET, or MRI, you can see which cohorts have collected. And you'll see there's lots of crosses, but that doesn't mean to say there's not lots of ticks as well. We also have a genomics matrix for those interested in genomic data. And so we really do provide the resources to run multimodal, multi-cohort analyses. This is the login. It's a two-step secure login process. Once you've submitted your proposal, you're given a password and you use a Google Authenticate key to log in, and we will give you a desktop which is suitable for your analyses, whether that's a standard, an extra large, or a Linux desktop. And this is the desktop. So it's just the same as if you had your data on your PC at work or your laptop. There is no internet connection, but there's pre-installed software from SPSS to SAS to Jupyter Notebooks to Stata. So, and this is all free for your research. Do come and ask me if you want to know more about the data portal. So now I would like to welcome Emma Stone from Alzheimer's Research UK. And I'm not going to tell you what she's going to talk about, but it will be all things that ARUK can help you with your career. Thank you, Emma.
I just want to say it's lovely to be here today and see so many of you here. We are very passionate about ECRs as a funder, so it's really nice to be able to talk to you about all the different opportunities that we have available. So I'm the Research Programmes Manager for ARUK. I look after a whole host of different things, but one of those things is our ECR programme. So before I delve into all the different things that we have available for you, I wanted to touch on why we do what we do and sort of the background for it. So our ECR programme came out of the pandemic. We noticed as a funder that ECRs were the hardest hit group in terms of funding opportunities, networking, career development events, things like that. So we convened a working group with ECRs from across the country in 2021 and came up with these sort of key themes that we wanted to work around. So firstly, to increase and sustain early career workforce. So to help this, we've introduced new funding pots, such as the ECR Bridge Fund, which I'll talk about later. The second point, we wanted to ensure that researchers, particularly those from currently underrepresented backgrounds, had access to training opportunities, networking events, to really help develop a broad set of skills. Third, we wanted to increase collaboration, both within the disciplines and externally. So we do this through a range of events that we have, such as the Early Careers Day ahead of our research conference, but also through our network centres, and all of these things I'll tell you about in much more detail soon. Lastly, but not least, we wanted to engage with wider sort of ARUK programmes. For those of you who don't know, we do so much more than just fund research. We do lots of policy work, public engagement, science communications, the list really does go on. We have resources for these that are available for free on our website, but also we really want to work with you. This both strengthens your career and helps you get involved in different things, but also makes our work so much more impactful to have ECRs like you involved. So, onto the stuff that you all really care about, the money. We have lots of different funding available to suit different career stages, different project types. As you can see, this is just a few of them. Something that I do want to highlight is our Early Career Researcher Bridge Fund. It's a really small pot of money, it's £30,000 for a short period of time, so for 6 months. And this is to help bridge funding gaps. Perhaps you're a PhD student that needs a little bit more data before applying to a fellowship. There's really quite a lot of flexibility with that, and it was the main scheme that we introduced as part of our ECR programme. At the minute, we're kind of reviewing how we do things at ARUK in terms of our grants, so some of these might change slightly, which is why I've put the QR code on the screen, which will take you to our website. That means that you can keep up to date with all the latest funding and everything that's changing. But for now, there's two things that are opening soon. We have our Clinical Research Fellowship and our project grants. As an ECR, you are able to be a co-applicant on a project grant. So if you're looking at perhaps taking that next step, or you're potentially more senior, this is a really lovely opportunity to get your name on a grant and be one of the leaders of that project. I have all the information about eligibility and different funding that fits into all these. So if you have any questions, please come pester me at the stand. We're more than happy to help and talk to you about any sort of particular questions that you have. If you are lucky enough to become an ARUK grant holder, there's lots of support that we do offer. The main thing that's worth mentioning is the training and development opportunities. We really, really encourage you to include budget for training when you're applying for a PhD or a fellowship with us. This can be up to £1,000 per person per year, and it can be used for anything. People have used it for the EMBO Lab Leadership course, Equity, Diversity and Inclusion training. There really is kind of no limit on that, as long as it will help build your career. And it's a really nice way to kind of make the most of that pot of funding. Secondly, we have an annual Connect Day. So all of our lovely funded ECRs come to our headquarters in Cambridge. We run different training sessions with them. Previously, this has included things like how to deliver yourself with impact, your personal branding, talking about your research, grant writing, and it's a nice way to meet your fellow cohort. And lastly, you'll get access to our ARUK conference and Early Careers Day, which I'll talk about later on. So aside from funding, there's different ways that you can get involved, which will really help bolster your career and just kind of strengthen your CV. Network centres is a really lovely one. So we have 12 centres across the UK with 3,000 researchers registered to those. It's completely free to join. You just follow the QR code and sign up on our website. If you are a member, you will be able to apply for these different grants. So centre-administered grants. Sorry, we've moved on too fast. Centre-administered grants, including travel grants, equipment, and pump priming. So it's a really nice way to get smaller pots of money. You'll also have access to local events. So this could be local conferences, ECR training. There's lots of different things going on locally. Also, I just wanted to say that sometimes ECR representative positions come up within the organising committee, and it's a really great way to kind of lead your peers and start to develop different training for your colleagues. So I might be slightly biased because the ARUK conference was my baby this year, but I thought it was really great, and it was a lovely way to kind of hear the latest in dementia research. So we had leaders from the field, both in the UK and abroad, and next year it's going to be in Birmingham. It's a really great way to build new collaborations, network, and also present your own research. Once we've finalised our themes and sessions for the conference, we open applications to ECRs to submit their oral abstracts. This means that you could be presenting on the main stage at our conference, and it's a really fantastic way to get your research out there and also a skill for you to build. All of the oral abstracts are reviewed by our fantastic programme committee, and they rank and score them and decide who is best placed to speak. If you're awarded this slot, you'll also be given £250 by the De Laszlo Foundation as just a little token, as well as complimentary access to the conference. In addition to presenting in the main conference, you can also present your poster. So I'd really encourage you to present and apply to submit your poster, basically, and you could potentially be selected to do a flash presentation. So if you are interested, you can register your interest for Birmingham 2025, so you'll be the first to know when registration goes live. There are lots of prizes that come at the conference, and it's definitely worth keeping an eye on these. Probably the biggest one is the David Haig Early Career Investigator Award. So this is awarded to the most outstanding ECR in the field. It's judged by leading neuroscientists across the UK, and is kindly supported by one of our lovely trustees, Caroline van der Broel, after her husband, David Haig. So you will receive £25,000 in research funding and also a 1.5k personal prize, which, is pretty good. Next up is the Jean Corzan Prize. So this will be opening in the autumn, and we really encourage you to submit your paper. So if you're a PhD student or an MD student, any paper that you've submitted is eligible. So if you have been selected for that, you will receive £2,500 and have the opportunity to present at the conference. So you can see our lovely Jean Corzan winner this year presenting her work at the conference as part of the main programme. Next up is the Laura Pulford Prize. This is awarded to the best PhD talk delivered at the Early Careers Day, which is judged by our science communications team. And lastly, the Poster Prize, which is awarded to the best poster presentation as judged by our delegates. Next up is the Early Careers Day. So I've kind of touched on this a little bit anyway. It precedes the ARUK Research Conference and is designed specifically for ECRs. Each year, we convene a new program committee with a bunch of ECRs from the local area. So this year, it was designed with the Northwest Network Centre ECR reps in mind. We worked together to create a tailor-made program. It covered all sorts of stuff this year. We had discussions on journals and academia, different resources that you can use for dementia research models, and science communication. So there's a real range. I think a highlight is always the careers panel and kind of seeing what different opportunities are available to you as an ECR. It's a really lovely networking opportunity. You can meet with your peers, present your research, and it's just quite a nice atmosphere as well. So it's really lovely. Also, we have a really great networking event this year was at a 3-story arcade bar. So, it's very good fun. Lastly, I just wanted to mention some resources that we have available to you. They're all available on our Early Career Researcher portal. So there's lots of kind of tip sheets and guides on everything from how to write a lay summary all the way to lab tours. Everything that you could want really is on there. You will find all the latest updates in terms of funding opportunities on there as well, and also different communities. So things like Dementia Researcher, for example, or the UK DRI ECR network. You can also use this link to sign up to our researcher newsletter. This goes out every quarter and has all of the latest updates, both for ECRs, but also wider researchers. So with that whistle-stop tour, I am done. We do have a stand here for the rest of the conference, so please come and find us. We're very friendly and we're more than happy to chat about any questions you might have. Thank you.
I'm joined here by Alan, and I'll let Alan introduce himself.
I'm a research network volunteer with the Alzheimer's Society. I was a carer for my late mother, who lived with dementia. She lived with dementia for 15 years, and I was a carer from beginning to end, including end of life. I've been volunteering with I started with Joint Dementia Research back in 2015, which is a joint partnership which includes the Alzheimer's Research UK and also the Alzheimer's Society. And then I actually met some early career researchers at a dinner in London that I won a place with one of the Alzheimer's Society schemes. And I sat on the table, and it's fair to say I was really inspired. I've always had an interest in research, and so that's the start of my journey. And now I'm talking around dementia, 1995 through to current day, and I'm still involved. And thank you very much for having the opportunity to come along today, Cherie.
Yeah. Thank you, Alan, for joining us. So today we'll be talking about the importance of patient and public involvement. We'll speak a little bit about what PPI is, and then when and how to meaningfully involve people affected by dementia, and then making sure you know how to show this in your grant applications as well. So firstly, what I'll go into is kind of the Alzheimer's Society and research and what the difference is between these three areas of involvement. So we've got participation. That's where people are recruited to clinical research studies, and the research results are based on the data that they provided. We've got involvement, which is research studies that are carried out in partnership with people affected by dementia. And then we've got engagement, which is sharing information and knowledge about research. And it works best when you involve people affected by dementia when sharing those. So these terms can be used quite interchangeably, and we just want to make sure that everyone understands exactly the three different terms that we're referring to when we're talking about this. So our research network that Alan has very kindly joined us today, we've got 300, just over 300 volunteers, and that's one of the ways that we work in partnership with people affected by dementia. So they're all experts by experience. They all have a lived experience of dementia. And they get involved in lots of things at Alzheimer's Society. So such as they lay review all of our applications that come in. They monitor all of our funded grants. So they'll meet with them every 6 months to a year and speak to them about their experience. And they're really kind of, experts by experience. So they lend a hand into what the project is going into. They can influence our strategy. So the research team in particular comes to our research network a lot of the time to talk about what we want to do with the research program. And they're also partners, they also help in our partnerships and our grant application development. So I'll hand over to Alan to talk about how you got involved in research and kind of why you joined the research network.
Thank you very much, Cherie. Yes, I was a statistician by trade when I was working, and so I always had an interest in things like that. And it's a strange way that I really got involved, because when I was caring for my late mother, my father died 8 years through the journey, and so I took over the full caring role. And I used to keep calendars, and those calendars I wrote down what her moods were, what her eating habits were, how I used to record a diet and things like that. Because to look back on, why did I do it? I don't know. But I just found that if she had an up day and a down day, that helped me to answer. Maybe she hadn't eaten very well that day or something else. And I went along, annually, the Alzheimer Society have an elf day. And I went along to Bath Christmas Market, invited by Joint Dementia Research to wear a hat and be on the stand there. And I joined with some research nurses that were there for the day. And I got chatting to them. And I thought, there may be an opportunity cropping up sometime in the future for me. Literally 3 months later, I got contacted by their Bristol area university that they were connected with to say, we've got a conference coming up soon in Bristol. We'd like you to speak at it. So I thought, okay, fair enough. Oh, by the way, we want you to do a radio interview with one of our professors on Saturday of this week. And the program will be going out live. Okay, fair enough. So I went along and met the professor on the day. The doctor was a gentleman called Dr. Phil Hammond. He's well known to quite a few people. And when we were in discussion, one of the things he turned around and said to me was, you know those calendars you've got to create a living diary. And he said that living diary can be so important for people. And I carried on doing that from this day. I met him at a function that he did somewhere else. And I said, I've created the diary, and wow, what a difference it makes. So that was how I started to get involved. And with the early career researchers, as I said, it was at this dinner, which was actually in London, where I won a place. How do we as research network volunteers get involved? You start off basically by looking at grants that are coming in. There can be a lot of grants, can't there, Cherie? There can be a lot of grants that we're looking at. And then people start to grow through the research network. They start to gain experience through it. And then you move on to actually monitoring grants. And usually there's three lay people, as we're called, that look at these grants. And when a grant is appointed, we apply, and then we get placed. It can be, usually they try to keep them close to our home areas. But I mean, I've been on grants in Sheffield because that was to do with strokes, because my late mother had vascular dementia, and she developed that through the strokes that she'd sort of had. And then from there, the next stage up you can make is join what's called the Grant Advisory Panel, which is the next stage on when the initial rounds of grants applications are looked at. Also, you can serve on the Grant Advisory Board, which is scientific experts, and there's also lay people that sit on that too. One of the other things is there's something called Centres of Excellence. And with the Centre of Excellence, when they're recruiting people, as research network volunteers, we very often come along and help along with the interviewing process.
So, yeah, essentially all this to say that we have our research network and they get involved obviously quite a lot with our funded researchers, but we do have them that we have a partnerships program where people can apply to us, and if they need research network involvement or someone with lived experience, they can come to us and ask for that at the beginning of their proposal. So we've kind of gone into this a little bit. So let me just go into when to involve people. So this is a big question. And I know a lot of people kind of struggle with when we should start involving. I think we all know that we can evolve throughout, throughout your project. But what I really want to stress is at that beginning stage, that identifying and prioritizing phase. So this can be through identifying and prioritizing that research question and the outcome measures which you're trying to do to be meaningful and relevant to people affected by dementia. This includes that consultation, collaboration, and co-production in the middle. So that could be consultation where, for example, you ask a group of people what their views are for a certain question you might be looking at, and that could help develop your research idea. You've got that collaboration, which is that ongoing partnership with someone. Or a group of people affected by dementia. And then you've got that co-production, which is an approach whereby researchers, practitioners, public health, and people affected by dementia all come together from the very beginning of the project to generate knowledge and go through the project. So Alan, I know you've been involved in all these 3 types of involvement. So I was wondering if you could give us some examples about that.
Certainly. One of the things I think with the 300 network volunteers that we've actually got, we've all got different levels of experience. There are people that are actually caring currently for someone. There are people that actually live with dementia. And there's also people like myself who are former carers. And that's what attracts a lot of us to get involved. And one of the things is sometimes you start to look at the early part of an application and you can actually think, oh, they obviously are doing PPI, but it isn't really highlighted as such. I think that's one of the things that that we really notice. And so we've actually got the facility now within the society whereby if someone's planning to apply for a grant, they can also have the opportunity to have research network volunteers look at it prior to submitting that stage of application as well. The range of stuff, that's the range of stuff for the society. And there's also NIHR grants and a number of grants, ARUK, Wellcome Trust, and many like that. And they can range from dental to sleep to tau. Also something called fastball. I was involved in a fastball trial in the early stages, and that was a non-invasive, looking at non-invasive brain waves, how you can be shown a series of pictures, 12 of them, and then a couple of minutes later you're showed another 12, and you've got to pick out which ones were there that you started with. And that's gone on to a very, very large grant as well. And we're talking about research for patient benefit.
Yeah.
Cherie.
Yeah, definitely. So moving on to the next slide, which is meaningful involvement. So one of the things and one of my tips for meaningful involvement is to be creative. So you need to allow time for that relationship building with different groups of people, especially at the beginning. So we recently had an application from someone who sat in multiple PPI groups locally and really thought about that diversity aspect. So spoke to people from different communities. And what they did was they just sat in these different groups and they listened to them and listened to what they were saying. And they formulated their research question based on that. When they spoke to us in the interview for their grant application, that was one of the things that our grant board was like, that is what makes a good PPI. That is good PPI. So I just want to recommend when you're thinking about your application and thinking about your proposal and thinking about how to do PPI, be creative with it. Think about other groups that you can approach. Think about when you're starting. Don't start thinking about it as a afterthought, once you've written your application, you're like, oh, there's a PPI aspect, because at Alzheimer's Society, PPI is such an important part. And as Alan has said, we have our research network sitting on all of our boards, and they can influence the decision of if your grant is or proposal is funded or not. Another thing is planning together. So you need to ask people how they want to be involved. Don't just decide for them exactly, what you think the involvement should look like. You need to think about kind of what relevant skills and experience they may add to it as lived experience people. And you need to develop that PPI plan to sit alongside the research plan. So ask them when they would like to input, how they would like to input, and not just go at it thinking what you want to do. And then we've got all these different involvement roles that I think Alan has touched on a little bit as well, which is you've got co-applicants, you've got collaborators, and that co-production we spoke about earlier. And I know, Alan, you've been a co-applicant for a study, so I thought it might be good for you to speak about that.
Okay, thank you. Yeah, earlier on I mentioned about wearing the elf hat in Bath, where I got to know some people afterwards. And 2 years on, I got contacted by the same people, and they said, we're putting in a grant application. It wasn't to the Alzheimer's Society, it was to someone else. And would you be interested in becoming a co-applicant for us? Because we want to involve right at the start. Before we even put the suggestion in, we'd like to say that we consulted with someone on PPI from the lay scheme. So I said, okay, fair enough. And one thing I discovered, how long some of these processes can take. I didn't realize how long some of these processes can actually take. And that particular study got funded. It ends at the end of this year. And it was somewhat on MCI, mild cognitive impairment. And it was something to be used in clinical practice. And it was a qualitative to come on. But what they did, they set up 3 stages. They actually have a PPI group that meets. I attend, and some of these are hybrid as well, so you don't always have to be there. And that's one of the things that's come out of our experiences back in 2020 and 2021. And so you have hybrid meetings, and then I have a group of about 10 to 14 people that will discuss things. We then have a steering group which follows on, and then we sit down with the people that are scientists that are involved in it. And so then we discuss about it. So I like to think of it as like a ladder, and that's a 3-pronged ladder. And I've been fortunate enough to be part of that 3-pronged ladder.
And I think something just to say around that hybrid function is when I was saying think about how people want to be involved and plan with them, something that we've seen since the pandemic is because people have care and responsibilities, it's much easier to have online meetings and make sure that they can be hybrid. But that face-to-face is also really important because once we came back out of the pandemic and could start doing more face-to-face things, I know a lot of the research network was really keen to come to meetings, and with the monitoring meetings as well, go to the labs, see the labs, etc. So I think when you think about how to involve people, think about that aspect of it that's come from COVID, which is, hybrid or face-to-face or online, and make it a mix so that people can choose exactly what they want to do. So going on to the next point is kind of around diversity. So equality, diversity, inclusion, and making sure that you're involving people from a wide range of experiences. So I am a Black woman and I'm from Kenya. And what I do, because I've been working at the society for 3 years, I quite like to talk to people in my community, my parents, my family, quite a lot about dementia and their experiences of it and what they think of it. And I remember I spoke to my mum very early on after I'd finished my degree and I was starting working at the society. I remember speaking to my mum and I was like, so what do you know about dementia? Kind of what have you heard about it? What teaching did you have because she grew up in Kenya? And she was like, oh yeah, your granddad kind of has it. And I was like, kinda? What do you... Kinda? What do you mean? What does kinda mean? And then she said the diagnosis, if you can call it that, that he got was that he has a little bit of dementia. And just setting the scene, the diagnosis he would have got was in kind of, whenever I go back to Kenya, I visit my family and my grandparents in a village. And he had other problems that were more paramount. So that dementia diagnosis wasn't meant to be kind of the key point, which is why it wasn't explored that much further. But what I'm trying to get at with this is the teaching and learning from people who are coming to this country, for example, like my mum, and I'm a first generation. They don't have as much learning and they don't have as much understanding about dementia. So when you are going out to when you are going out to diverse groups, which you should be doing, you need to think about exactly what the knowledge gaps there might be. The barriers, for example, barriers to people in my communities and other communities not really having that much trust in healthcare providers. And kind of more so as well in by extension researchers. So think about the barriers there are to accessing more diverse groups. I think, Alan, you have a really good example of how you thought about those barriers when speaking to a group.
Thank you very much. And I will add, that's the first time I've heard Cherie's talk there. And thank you very much, Cherie. Yeah, and ironically, this will cross paths with something that happens to me. Because I get involved in talks for legacy, fundraising and things like that. And in my local community, people get to know that you're involved around dementia and that. There was a group called the Multicultural Friendship Group, and I had an invite from them to go along to speak at one of their afternoons. I think there was going to be about 40 to 50 different people there. And so what I did a little bit in advance, I spoke to the organizer and said, can you just explain a little bit to me about the people I'm going to encounter there, so that I can understand. One of the things that surprised me even was how the word dementia is used differently from people from European countries as well. And it also enables us to sort of say, what sort of pace do you want me to do that talk at too, so that everybody can understand. And by pacing it and finding out from an organizer before, it helps you to get to know the people that were there. And I think that's one of the real important things too.
Yeah, thank you, Alan. So you've actively involved people affected by dementia in the planning of your proposal. You've done all the things we've just said. So now what? Well, you need to show it in your application. Something that we don't see a lot of is people showing it in their application well enough. I think we, as funders, we look for evidence of relevant partnerships established early on. We want to see a clear and inclusive involvement plan, and we want to see that plan embedded into the research plan. Another thing is kind of a reasonable budget to support the involvement that you've described. So we've seen, and I think we've touched on it a little bit, that PPI can be absent in applications. Alan, do you want to share the story about the person that you were involved with?
Yes, certainly. This was on a pre-application, and I mentioned about that a little bit earlier on, about the pre-application. And it was very obvious that the person in the pre-application had included people, but it didn't seem to be coming over as part of what would be looked at by that group of people. And in the application there, we get a little 4-comment form that we can actually fill out. And those comments can be fed back as our comments to the researcher, or they can be fed back to the society if it's something that we want to feed back privately. I always believe in what you want to say, you should say it. And that's always been my sort of philosophy. And so it actually said, when I contacted back, it's obvious that the person that's putting this application has included PBI, but if they can include that at the start, that can make such a difference to the way that an application is looked at.
And I think we've got a really good example where us as funders being involved with kind of our research network and co-producing. So we co-produced, me and Alan and another member of the research network, John, we co-produced a presentation and a webinar to people who were wanting to be funded by us about PPI. And in that, Alan, you spoke about including a glossary. Do you want to quickly...
Certainly, one of the things that came over from some of the grant applications we used to look at was that some came in from places that must have had that little bit of extra knowledge, or maybe there was something else that was available. And I think having a glossary, I've been involved in volunteering for the NHS in my past, and that was one of the things that they used to include. So it meant instead of us having to look up as a lay volunteer, including a glossary on an application that comes in with maybe 6 or 8 items, it saves them being repeated during the application and gives that very important space that you want to include as well. And then it saves people having to go to, and I say ... And if you work that out, it begins with the letter G and ends with the letter E, because you can go there and you can see so much different things. If you can get that message over at the start, that is so important.
So with Alan and John talking about that in our webinar, we saw an influx of applications that included glossaries, and it actually showed that some people that had included a glossary were more likely to be funded by us. So that's a top tip, and we can share that webinar as well with anyone if they need it later on as well. So what do our volunteers think? And I'm going to hand over to Alan completely for this.
Right, okay, fair enough. I never believed when I started my caring journey that I'd end up being at somewhere like this. I've been fortunate enough to attend a number of places, and I got some very, very good friends. One of the things about the network volunteers, we become friends with one another. The ECRs and the PhDs and some of the scientific experts, we actually become friends and that sort of thing as well. So one of the things that I also wanted to know about, and I'm thinking you made me think about the animal situation, Cherie. I mentioned a university earlier on that I went to. I won't name the one now because it's unfair on other people. But I went to attend as a monitor a meeting, and I went out for a break, and I was sat on a bench in the gardens of the university. I had my Alzheimer's Society volunteer badge on, and someone came and sat down next to me, and they said, "Oh, you're a volunteer. How did I use to volunteer?" So I sort of explained, and I said, "Oh, I love being a part of the research network." But one of the things that I wonder about sometimes is animal research. You hear all these things about it in associations. I thought no more of it. And about 6 weeks later, I had a contact from the university to say that they were going to actually be staging a behind closed doors event to explain about that. So a casual, some of us may know about the film Brief Encounter. I had a brief encounter with someone where we were eating in the grounds of this university. And the next minute I went along to this event. And it really, really opened my eyes up to what was involved. I have been fortunate enough to go to a laboratory as well during some of the monitoring, but this bit really opened my eyes up, and it gave me a lot of confidence as well.
I think that's just such a fantastic example of meaningfully involving people. Just a chance encounter and a chance conversation, and that researcher decided, okay, well, let me show you. And now you're still connected with that researcher today, aren't you? Yeah. So just to end really quickly, we have our ECR retreat this year. It's on the 18th and 19th of June, and it's at the Vaco St. John's in Solihull. Who can come? All ECRs working in dementia research are welcome. We have just a couple of spaces kind of left, so we're really encouraging more people to apply to it. And what is it? It's an opportunity to network and learn valuable skills. We're going to have lots of workshops. We have a panel talking about grant writing. We've got senior ECRs talking about their experience in going from kind of a PhD stage down to, quite senior, several postdoc positions. So I would just say, if you are interested in coming, please come. I know we've got a network workshop as well, although we'll really be going into the nitty gritty of PPI in our program. But yeah, just thought we would mention this. But thank you so much to everyone for listening, and thank you, Alan, for sharing your experiences. I guess I'll hand over to.
Thank you very much for the opportunity.
Now it's my turn to give a little bit of a talk about training and mentoring. I realized at the beginning of the event this morning, I didn't even introduce myself. But so I run a few programs of work using the DPUK resources as an associate professor at Oxford. So I have scientific programs looking at early adversity and later life brain health and modifiable risk factors for dementia. And so I have a great team of early career researchers. But through my work, I've also identified as the scientific reviewer for DPUK that many researchers really struggle to access affordable and accessible training. Now, for those of you who do hunt down training and include it, for example, in your grant applications, you'll realize sometimes that's a huge cost and a huge chunk, both training and conference attendance. So also working with large multi-cohort, multimodal data sets is a real different beast than taking your 200 or your 100 participants that you've collected as your PhD or DPhil project. It takes a different type of interpretation for both the analyses, but also simply managing these large data sets alongside each other. So what we've done at DPUK a few years ago, we established a training program for researchers that is really focused on big data sets, multiple cohorts, and multimodal. So the training hopefully provides and delivers on a need which is at the moment not met. And we also keep these to very affordable, £125 for 5 days training, which I'm sure you'll agree is much better than some of the other offers out there. So why do we think that training is needed? It's not that we think that the researchers are lacking in knowledge, it is just applicable skills. So we have over 1,000 users on DPUK across the world. So we admit we've still got to reach out to the African continent, but through our partners at IHCC, we're busy doing that at the moment. But we have researchers all over the world. So another aim of our training program is we actually took it online during the pandemic. They used to be in person, but we've realized we can actually reach a much further spread around the world for our training events. Now, the Datathons were our first training event that we rolled out in 2017. And these used to be 3-day in-person events. They're now 5 days online, like our academies. And this is where researchers can come along, have access to around 6 cohorts. We stage a scientific theme. We divide everyone into groups according to their experience and their institution and their background. And they have 5 days to tackle these data sets and come up within the scientific theme with some output in 5 days. Now, that output might just be understanding the data sets and running a few descriptives, but these are really popular events. And some of these groups have actually gone on to develop their projects even larger. They've created collaborative networks. And these have produced publications. We give access for the Datathons to an additional 12 weeks to these 6 cohorts in the virtual desktop interface. And I actually run the mentoring myself, and I work with the groups so that they can actually have an output from their participation at a Datathon. So who can take part in Datathons? So as I said, they're 5 days. They are not teaching events. So if people turn up for these expecting teaching, there is no teaching. It is more collaborative learning from your colleagues in a group and making friends, which you can take forward a publication. I've already said about the 12 weeks. The entry requirements, you have to be a researcher, either in academia or industry, some experience of processing data, and that can be however small. It just means that you've got experience of actually looking at data and running a scientific question. So if you've only got SPSS knowledge, that's fine, because you'll be put with a group with a programmable language knowledge. We do ask for an application, a CV, and preferably an interest in healthcare and dementia. These are the events that we've run over the last few years. We don't make them too big. We try and make them, well, we're actually capping them now at 30, so that we can keep it a manageable group to take forward for a publication. And the important thing is our next Datathon is the 8th to the 12th of July. And please do visit our website to express your interest, because the Datathons do fill up exceptionally quickly. And these are some of the examples of projects which have been taken forward from these datathons: lifestyle and the risk of dementia, cognitive reserve, one looking at walking speed and cognitive impairment, and hearing aids, and even sensory deficits. Some of these projects are still running today. Now, and we also have the academies. Now, these are for teaching, and this is really to meet that unmet need, providing cost-efficient training. We have an elementary academy in the spring. We've got that coming up in 2 weeks. That is full now. It was very heavily oversubscribed, and we had to cap it simply to make it beneficial for everybody. The elementary academy is aimed at researchers who perhaps haven't done statistics since their undergrad, or clinicians who have not really had hands-on experience with data. So we work with partners at the University of Edinburgh, Dr. Tom Booth, who comes and runs his program for us online. And that, again, is really popular. We then have an advanced academy, and that is run towards the end of the year in the autumn. The idea is that people take part in the elementary, they develop their skills over the year, and then they're ready for the longitudinal advanced academy in the autumn. And so the advanced academy, we cover every day for 4 days: Cox regression, machine learning, structural equation modeling, and survival analyses. So those skills need to be developed from the elementary to the advanced. And I think the formatting is all jumped out on my slide, but elementary academy is full. The advanced academy will be advertised during the summer, and that will run from the 4th to the 8th of November. Now, coming in 2025, we're expanding our training program, and we will be running a genetics academy, an AI academy, and a structural equation academy. These will not be 5-day events. These will be more 1-day workshops. And again, these will be held online, and so that they're accessible for everybody. This is an example of a program. And what we like to do is we like to have a few talks in the morning so that it's not just all teaching and all data. And this is the Elementary Academy coming up. And as you can see, we have a person with lived experience of dementia speaking. We have ARUK come along and tell us about funding. We have a couple of exemplar scientific programs. And so we try and have the balance of an hour of talks in the morning, just so that while people are doing their data, they can think about their academic career as well. We're also developing a DPUK researcher hub. Now, we did launch this last year, but we were still trying to gain feedback from early career researchers about what they really wanted with a researcher hub. And we were developing a mentoring scheme, but then if we did the mentoring scheme, we needed to then reach out to the mentors to sign up. But what we've come up with now is working with the International 100,000 Health Cohort Consortium, IHCC. I'm on the steering group and a member of the IHCC. And like DPUK, they have researchers, but also cohorts all over the world. And so what we're doing is we're working with them to develop a remote mentoring program. This will be officially launched in August, but if anyone is interested about this, please do come and chat to me. So the early career researcher identifies their mentor. They come to DPUK, and we set up the project on the DPUK data portal. That researcher then is mentored remotely by their mentor, but tapping into the training program of DPUK and the resources that DPUK offers. So there is no costly and very expensive mentoring visit, but that can be arranged at between the mentor and the mentee. But it could be just maybe a 1 to 2 day visit rather than a 3-month or a 6-month expensive visit. So I will be leading this program of work, and I'm happy to answer questions about this.
I'm Delia. I'm based in Cluj, Romania, and I'm still a part of, I'm going to call it this little family here, which is very nice. All right, so I'm going to just talk a little bit about our program of work, which I know that some of you are familiar with. So it's called the Blossom Early Adversity and Brain Health Program, and it's led by Professor Sarah Bauermeister. With respect to the brain, our overarching aim is to understand the long-lasting consequences of adversity and of stress in general on the brain and on the aging brain as well. What are the protective factors, what are the risk factors, and really tapping into known and important theories that are yet to be demonstrated, such as the biological sensitivity to context theory, which really talks about a genetic predisposition towards stress reactivity, a certain kind of stress reactivity, which then might influence your neurodevelopment. And really, at the core of our program is to understand the mechanisms through which adversity might affect the brain. There is a long history of literature in this area as well. However, there isn't yet a consensus on this. And there might be many reasons for this, but really one of the main problems, one of the main challenges might be the fact that it is difficult to study adversity. Of course, it's difficult to study adversity with observational data, but really just because of the breadth of definitions surrounding adversity, severity, difficulty, co-occurrence, it's just a very difficult topic to study. So what we do is we aim to gain benefit, but from all data that we've got in UK Biobank across cohorts, to at least try to achieve a good degree of causality within our observational data. So we try to integrate different kinds of data, such as genetic imaging, a lot of biopsychosocial variables, to test these what we think are complex but realistic hypotheses. So I'm going to give an example now. This is one of the studies that we're currently working on. This as part of the larger project. So here we're looking at how different kinds of adverse experiences that we identified in these cohorts might affect a region of the brain that is involved in reward processing. There's actually ample evidence that suggests that adverse experiences might be associated with reductions in these brain regions, as well as altered reward processing. So we used the NSHD cohort, the Insight 46 sub-study of this cohort. This is a birth cohort. We had about 400 people, and we used the FSL tools to segment those brain regions that I was talking about. And for adversity, we looked at maternal control, which is a subscale of the parental bonding instrument inventory. And we created 3 adversity categories, so that's just a distribution of answers. We also looked at UK Biobank. We had more people there, as you're aware. This is a large cohort. We used already available derived phenotypes of imaging data that was already there and analyzed. In the UK Biobank, you have several adversity and trauma variables, and here we used stepwise regressions to identify the ones that we wanted to move forward with. That's because the more complex the analysis becomes, the more you want to make sure that you control for as many things as possible, and you want to make sure that your false discovery rates are in check. So we went forward with 2 adversity variables, looking at emotional abuse and emotional neglect, and 2 trauma variables, which are derived from the DSM criteria for PTSD, and that's traumatic illness, life-threatening illness, and abuse. As I said, we tried to control for as many variables as possible, just through different kinds of methods, group matching, regressing out some of the variance of these confounding variables, and also running adjusted and unadjusted models. So we corrected within NSHD and DPUK for things like lifestyle, demographics, early life factors such as birth weight, cognition, mental health. In the UK Biobank, we also had more data about general health, so that was a good opportunity to also make sure that we controlled for what we call allostatic load, so things to do with metabolism, the cardiovascular disease, the immune system. Of course, all of these were very well controlled in terms of false discovery rates because we have such big data sets, right? And in terms of results, briefly, in the NSHD, individuals who reported adversity, so that's the high on the right in the top graph. So that's individuals who reported higher maternal control, so we called here adversity. Showed smaller so reductions in these brain volumes. We have the caudate in red and the putamen in green. And following corrections as well, these results remain significant in the caudate. For the UK Biobank, we see kind of like a similar trend, but only for the putamen. Again, this region is smaller in individuals who had reported having experienced traumatic illness. And importantly, these results were significant regardless of many health variables that we control for. And this is just to say that there's a similar trend for abuse as well. However, as I said, we were very strict with our thresholds, with our p-values. So we're looking here at less than 0.001. In terms of mental health outcomes, as expected, the results were a little bit more robust. So individuals who reported high maternal control also scored lower on well-being, and there's kind of like a slight dose-response effect, so that's interesting to see. And within the UK Biobank, those who reported even rarely, but from rarely to very often, occurrences of emotional abuse, neglect, traumatic illness, or traumatic abuse, they all scored higher on PTSD, depression, and anxiety scales. In terms of risk of dementia, this is something that we're starting to explore more and more. So what I'm showing here is the same analysis that we ran before. These are multivariate analysis, but we checked interactions with dementia risk because anyway, so in NSHD, we have the two SNPs, and we were able to compute ApoE4. And in UK Biobank, we already have polygenic risk scores for Alzheimer's disease, and which were dichotomized into low and high risk. And it was interesting because both of these showed interactions with dementia risk. However, it's basically showing us that those reductions in brain volumes, both in NSHD and in the UK Biobank, were really present in either ApoE4 non-carriers or polygenic risk or low risk. So we're moving forward to try to understand this. Of course, we see that some of the brain regions that we looked at were indeed smaller, and in some of the individuals who reported adversity, which is what we're seeing in the literature. However, it's important that this wasn't apparent for all kinds of adversities. And there's differences between the types of adversity. So this is something that we as a group, we're moving forward to understand how all of these kinds of experiences might have different effects from a biological perspective. How do we get there? It's interesting that there's more, it's important that there's robust effects with mental health as well. So maybe that's a route that we need to follow so that we can understand these differences. And of course, the effects on brain volumes were present in participants with low risk of Alzheimer's disease and ApoE4 non-carriers. Now, even in preclinical populations, these genetic effects could be apparent on the brain, so there might be some sort of masking effect there. But as I said, we need to carry on and understand this better. So what we're doing now, we're computing different kinds of polygenic risk scores as well to understand these interactions better. And we're looking across the entire brain and as well across functional networks. So stay tuned. This is part of my Marie Curie Fellowship. So this will carry on until 2026. So hopefully by then I'll be here and have very exciting answers for you. Thank you.
Thanks for the opportunity to talk today. I'm part of Professor James' Rowe group, as many of you probably know about him. The person here, and he's running a big research program to understand underlying causes of dementia, Alzheimer, and so on. And our group is relatively large, including nurses, clinicians, psychologists, people like me, computational neuroscientists, and so on. And today I'm going to talk about the reliability of our translational modeling tool known as dynamic causal modeling from MEG data. Ooh. So to start with, the DPUK aim is to open the bottlenecks in drug development for dementia to de-risk, accelerate early phase clinical trials with new in vivo assays that are sensitive to the presence of the disease, sensitive to the progression of the disease, elucidate disease mechanism, identify drug effects, and to be trial ready, which means scalable, reliable, and so on. So our focus here is not to give you any disease mechanism, but to say that our translational tool is reliable when it goes to repeated measure of the same event. So to set the stage, I should start with a little bit background about MEG, or magnetoencephalography, to study pathophysiology of dementia. So as we all probably know, neurons generate electrical field, and this kind of electrical field can be captured by so-called EEG device. And this is pretty cool. But there is a magnetic field around this electrical current, which can be captured by more advanced device like that we call it MEG. And this device has been found very useful and less distorted by artifacts like school artifacts or tissue kind of distortion like EEG. So it gives us a clean picture of neuronal activity in the brain. So itself is safe, it's well tolerated for dementia patients, and it's excellent to distinguish different types of dementia, therefore enhance drug trials. So in addition, what we want to discover is that what's causing the brain activity, what is the underlying generators of this activity from this sort of data. So this is our agenda, and it can pave the way for precision medicine, understanding underlying mechanism of the disease, can help clinicians to better create treatment strategy and so on. So we need, as part of that, we have the brain activity. To start with, we need to have a system of a brain that engage with particular type of activity. For example, as probably some of you are, for instance, doing mismatch negativity paradigm, oddball paradigm. This is the network that involved in generating such events, so just responding to some stimuli. Or if you're working with the resting states, there is a standard network that you can study. But underlying each nodes in this network, we have kind of biologically driven model or biologically informed model that is laminar specific, and laminar specificity is very important for studying neurological conditions because, as you might know, some surface in your cortex might be affected by these diseases, like, for instance, in frontotemporal dementia, superficial layer may be targeted by disease, you have some damages, and you want to have such LUMP model to be able to understand these kind of mechanism. But also we want to know some detailed physiology, like changes in the ion currents and dynamics like GABA, AMPA, and so on, so that if you like to study the effects of drug, you can understand, you can understand how this drug affects your brain response. So the good thing about these models, apart from this complex kind of formulation, etc., is that they are tractable. It is possible to infer them from real data. And the way that we are doing that is through a framework known as dynamic causal modeling, originally developed 2 decades ago by Carl Friston at the UCL. So all we are doing is to take a model, we assume some structure, as I mentioned, underlying the generation of that model, and then having some prior information about synaptic physiologies in this model, and try to integrate that, try to identify that from our real data. In other words, all we are doing is to adjusting the model accuracy penalized by its complexity, which is known as model evidence, by changing the ion dynamics like AMPA, GABA, NMDA, and so on, to have something that we call it model prediction versus observed data, which can tell us how well our model can create or recreate the activity of the brain network, but also have an idea about how our ion or effective connectivity, whatever physiological variables should be defined to replicate such prediction, as well as a very important score for you as a user probably, to know that which hypothesis associated with the particular sort of brain activity, patient versus control, drug versus non-drug, are more likely to capture the essence of your experiments. And that's known as model evidence. And it's a really nice score because it's possible to compare it with different, for different sort of hypotheses, for example, H1 and H2. If it is larger, it means that it's more likely that this hypothesis is more likely to explain your data, your scientific question, probably. And this is the crash course on translational modeling. This is what I'm doing every day, and we try to improve it to make it available as a precision kind of framework, precise framework to understand different interesting questions relating to dementia. So all I'm going to now say from now is our preprint that we just is under review. So one of the interesting questions that you might say is that if I repeat 2 same experiments, can I get a similar answer? For instance, in terms of model evidence, you want to know if you want to conclude, if you conclude from one set of data set, can you get the similar sort of conclusion from another data set? And this is basically to check the reliability of our model evidence, basically the balance between accuracy and complexity of your model given your empirical data. But more importantly, you want to know the effects of drugs and so on, and therefore you need to have some sort of idea about the reliability of your estimated parameter, i.e. the probability distribution that you might get after your translational modeling. Having said that, there is a slightly little problem with the environment that we are working. So reliability or test-retest is like correlation, interclass correlation. These measures are basically defined for example, comparing IQs between group 1 and group 1 at the different time, etc. These are kind of isolated variables, singular variables. There is no uncertainty around them. And therefore, they are not directly applicable in our setting, where from our estimation, we get probability distribution function. So that's a little bit required some tweaking and theoretical work. So, but it is possible. So we can reframe the reliability as, we come back to the original definition of reliability rather than sticking with the mathematical equation, and say that if I do the same experiment twice, would I get the same answer? If I can formulate that and provide some evidence for it, then that should be logically sufficient for the kind of work that we are doing. So our data come from 14 subjects. So there are 14 subjects that were diagnosed with Alzheimer. And these participants help us by taking resting state MEG. So we have the first experiment within session between trials means that we recorded their MEG data, then we divide their MEG data in two parts, and then ask whether our conclusion from the first data set is similar to the second data set. They cooperate with us and come back in 2 weeks apart and retake the same experiment, redone the same experiment, and then we ask whether these two data sets, day 1 and 2 weeks apart, give us the same results. And then finally, we have these 14 participants. We select another set of 14 participants with exactly similar conditions. They are all having diagnosed with Alzheimer disease, and they are age matched. And then say that whether we can assess the similarities between these two groups. This is not exactly the reliability, the third experiment, but it's important for us to assess that. So we do our translational modeling in the usual way, take the model evidence, or I might call it free energy, but it's a fancy word for it, and posterior estimate of the parameters. So in terms of the assessing the hypothesis between different data sets, we find a very good agreement between the model evidence that allows us to make a conclusion about our hypothesis. Very good agreement between the model evidence. But also we run another experiment saying that reliability means to a degree exchangeability is possible between your data set. If you exchange your data in either way, you should get similar results. So that's the underlying definition of the reliability. Now, if in my mathematical model, I put this definition inside my mathematical model, would that be possible that I verify that through evidence kind of comparison? And the alternative evidence is that these two data sets are totally uncorrelated with each other. And if we do that, we get a positive evidence for between trials experiments when I cut the 14 participant data into two parts. When they've done the two experiments in 2 weeks apart, again, we have a positive kind of evidence for it, which is quite cool. But when it goes to the third experiment, which is not actually the reliability test, you have two different groups, 14 subjects, but they are different. So we are not repeating the first subject MEG data 2 weeks apart. We just take another subject which is kind of match or similar to this subject. We get negative evidence. In other words, it seems that these data sets are not compatible with each other. Reliability hypothesis is rejected, which is exactly what we wanted. Having said that, you might expect that at the end of the day, these two groups, the third experiment, within the third experiment, these are 14 subjects with Alzheimer. These are 14 subjects with Alzheimer. The underlying neuronal dynamics within this similar group should be somewhat similar. How you can show us the similarity? So then the answer is that instead of, as I mentioned, using interclass correlation and these kind of traditional measures, we're looking at the behavior of the group, something like averaging, but not a simple averaging. It's a sophisticated machine. We call it parametric empirical Bayes, but it stands for something similar to some sort of averaging. Basically, what it do is just creating the posterior probability associated with your group, given the data that you supply to it. And then you can measure the differences between this group in terms of such probability distribution. So all we are doing from now is to reinterpret the reliability in terms of agreements of what the group 1 shows versus the group 2, whatever, test and retest data, if you like. And if we do that amongst something like 200 physiological parameters, 97% of them are in agreement when it comes to the group 1 versus and group 2. Between trials, you cut the data, 2 weeks apart data in the second experiment. And we have a little bit drop in the third experiment. Basically, what we found is that slightly more differences, but it's in agreement. There is a predicted validity between the two groups. And this is pretty much answer the the question that I raised in the previous slide, that these groups should somewhat showing similarities in terms of the neuronal behavior as a group, but not one-to-one match, if you like, which the reliability requires. So further reading, so James started this journey of reliability of translational modeling in 2010, and he showed that model evidence is a good score for, is a very robust score for measuring reliability and so on. And then we start the path of establishing precision medicine. And by precision medicine, what you're doing, basically, you are trying to include as much as information as you can to this translational modeling, like PET data, MRS data, any empirical data that are available to you to have a more higher fidelity model, if you like, which we hopefully use it as a coin it as a precision medicine approach. And interestingly, by using this data, you can also improve the reliability of your model because you have higher fidelity model, more accurate model to capture the data. And finally, this paper, which comes out now and is under review. So I should say thank you to the participants and their sacrifice and their families for their help, and also thank you for your attention. Thank you, Sarah.
So I'm a postdoctoral researcher. I started in 2022, and I have been working in Dementias Platform UK project. MRI, brain MRI has shown, and it is a powerful technique for characterizing brain structure and function. And the image-derived phenotypes that we can extract from brain MRI can be used for translational research. But then for researchers, there are certain challenges that how do I access this data, or how do I analyze this data, or where do I analyze this data? And Dementias Platform UK and UK Biobank are these wonderful initiatives that are trying to address these challenges. So a brief introduction about UK Biobank brain imaging pipelines, where these pipelines have been designed to analyze data from UK Biobank. And for each single subject's data, it generates approximately 4,000 image-derived phenotypes. And what can be done from these image-derived phenotypes? Like you can see this scary-looking plot where each dot is a brain MRI measure, and it shows the association with non-imaging variables like lifestyle, physical health and cognition, and these kind of variables. So this is the power of UK Biobank pipeline. Now, coming back to Dementias Platform UK, Dementias Platform UK is a wonderful resource, and it hosts a data portal which has dementia data sets. And these dementia data sets also have MRI data. And DPUK also provides a remote analysis platform to perform the analysis. So actually, DPUK addresses the two challenges that I spoke, that how do I access the data and where do I do the analysis? So leveraging the potential of both UK Biobank and DPUK, in my postdoc work, I tried to integrate and adapt UK Biobank brain imaging pipelines on the DPUK platform. So we adapted the pipeline, and then we generate UK Biobank-like image-derived phenotypes, which can be further used to facilitate cross-cohort analysis. And given that the DPUK cohorts come from different sites and scanners, so we also included a data harmonization component. And then these UK Biobank-like IDPs can be used to further facilitate cross-cohort analysis, or also analysis similar to UK Biobank, or even comparative analysis to UK Biobank. But of course, there are certain challenges to consider while adapting UK Biobank pipeline on Dementias Platform, UK platform. And one of the challenges is the data and acquisition protocol differences, because UK Biobank does not have the coverage of elderly population, and the dementia cohorts are usually from the elderly population. Second is UK Biobank pipeline is designed specifically for UK Biobank data, which is acquired with UK Biobank protocol. But Dementias Platform UK has the dementia cohorts, which are existing data sets, and they have been acquired with different protocols, scanners, and sites. Uh, so because the data is from different sites, there is no harmonization component that is involved in the UK Biobank pipeline, but we have to include the harmonization component when adapting such pipelines. And then there are some computational and analysis related challenges. For example, UK Biobank uses its own file organization structure and file naming structure, whereas DPUK's data has been arranged in standard bits format. Also, UK Biobank pipeline is designed on a very different computational environment, and the pipeline itself is a complex form which uses multiple tools, packages, libraries, and programming languages to analyze different modalities of brain MRI. So this is a serious challenge in neuroimaging where the results are sensitive to different software versions and dependencies. So we tried to address all these challenges, and we adapted UK Biobank pipeline for analyzing structural diffusion and resting state functional MRI on DPUK cohorts. These are the default steps that the pipeline uses to analyze these different modalities. Now, what we did is to accommodate the file naming structure on the data portal. We first modified the entire pipeline to accommodate this file naming structure for DPUK datasets. And in the next step, since the data sets are diverse, so to generalize the pipeline across different data sets, we identified the processing steps which need specific attention, and then we adapted and modified these steps in the pipeline. And in the next step, DPUK analysis environment itself is a different kind of computational environment from the UK Biobank pipeline environment. So we changed or modified the implementation of certain tools that are utilized within the pipeline. So all this is bunched into one single pipeline, and then we now call it as desktop version, DPUK desktop version of adapted UK Biobank pipeline. And then DPUK also has a high performance computing environment. But it has a slightly different technical infrastructure. So we designed singularity containers of different tools that are utilized within the pipeline. And then we again combine all this into a single framework, and we call it as HPC version of adapted UK Biobank pipeline. So in summary, we generated two versions of the adapted UK Biobank pipeline. One is DPUK desktop version, which uses pre-installed tools on the desktop. And there is HPC version, which uses combination of singularity containers. And this all looks, or this may look very scary or quite a lot, but then users of the platform do not have to worry about this because we have clubbed everything into a single script, and that single script calls all these adaptations, and then users should be able to use it flexibly on their datasets and accommodate their dataset needs on the platform. Also, we have modularized versions that are designed to run these pipelines for any specific modality. So if some modality is absent, one do not have to run entire pipeline, but they can just take that modularized version and they can run the pipeline. And then we generate UK Biobank-like IDPs for each subject, and these are more than 6,000 IDPs for each subject's data. This is another work that we did parallelly, where we designed automated quality check classifier for T1 weighted scans with a specific focus on dementia datasets and elderly population in clinical datasets. So we designed this machine learning classifier, and which showed us that it generalized well with different patient groups and sites, and it also outperformed existing quality check tools. Sorry. And the QC metrics that we used in this classifier were also able to effectively capture the site variability. So there is a potential of using these tools to model the hyperparameters or the parameters of the harmonization methods that we are going to use on the IDPs. So in the next step, as I pointed out, we also need to consider the harmonization component. So we deployed existing harmonization packages on the DPUK platform, and we applied the adapted pipeline on two different data sets on the DPUK platform. And these two data sets were acquired from 4 different sites. And then we applied the harmonization methods on the raw IDPs. And you can see that the raw IDPs were quite different across sites, but after applying the chosen harmonization methods, we see more of a homogeneous distribution, and none of the IDPs were significantly different. So after doing all this, like what we want to do, and this is some analysis that we have been doing on memory clinic patients' data at Brain Health Clinic in Oxford. This is not done on DPUK platform, but this is how we would like to use the adapted pipeline, where on the x-axis you have different IDPs, and you can see the strength of association of these IDPs with the diagnosis. So basically, each dot here denotes, each dot has been calculated from the adapted pipeline, and then the pipeline, the images go through a rigorous quality control, and then one can do these kind of analysis. Basically, we can do such kind of analysis now on the DPUK platform with more data, because DPUK offers access to lots of different data sets. So in conclusion, the adapted pipeline, the harmonization tools, and QC tools provide a comprehensive framework to analyze DPUK cohorts, and all of this is going to be available on the DPUK platform so that users can use it. Also, raw and harmonized IDPs on pilot datasets will be made available to facilitate further novel analysis. And in the future, the similar framework that we have followed can be used and extended to accommodate other modalities like SWI, QSM, or ASL. And finally, integrating these imaging IDPs with non-imaging features presents a promising avenue for enhancing the predictive signatures within dementia cohorts, which can offer valuable insights into disease progression and potential therapeutic targets. So I would like to thank my supervisors, my co-authors, and a huge thanks to Dementias Platform UK for their support and this opportunity. Thank you.
I'm not an ECR. I used to be one. I'm kind of what you all want to be. Maybe a little bit, you'll decide. So I was asked to talk about working with complex data. And when I was a ECR, we were motivated by these questions. Why do older people lose cognition as they age? And what can we do about it? What can we do to prevent it? Most importantly, to prevent it, because nobody wants to develop cognitive impairment and then have it treated. All right, and yet people will develop cognitive impairment, and so we'll need to treat it. So we need to do both. Learn what causes it, learn how to prevent it. Prevent it in the sense of a common chronic disease means delaying the onset. Cognitive impairment and dementia are in a horse race. They're in a horse race with death. And throughout most of human history, death won. And now, increasingly, dementia wins, because we have succeeded in putting death to the other side of dementia. And now our job is to push death or dementia later in life to the other side of death. This was kind of the landscape when I first got involved in Alzheimer's disease. I was still a resident in neurology in the 1980s, but I've been taking care of Alzheimer's patients since 1986. And so here we have, in the United States, the two criteria that kind of solidified the field at the time, which is the clinical diagnosis of Alzheimer's dementia, and then a pathologic diagnosis of Alzheimer's dementia. And at that time, the logic was, does the person have dementia, yes or no? If yes, does the person have Alzheimer's disease, and can you confirm that pathologically? And that was your logic tree. The problem is that that logic tree began to fall apart right away, because it didn't take very long for studies to leak out of people who have the pathology of Alzheimer's disease, but either don't have dementia or through medical record review didn't seem to have dementia. And so this was the scene in 1992. This was the scene when I was a ESR thinking about what I wanted to do in my life as a researcher. And here's 1992. Anybody here born before 1992? All right, so for you, this is history. For some of us, we remember it. Chicago Bulls, Michael Jordan was on their way to their second championship out of what would turn out to be 6 championships. Very exciting time to be a Bulls fan. That was probably the only years in my life I was a Bulls fan. Dame Margaret Thatcher happened to be joining the House of Commons for the first time. Queen Elizabeth was holding her Jubilee. The Olympics that year were in Barcelona. Bush and Yeltsin declared a formal end to the Cold War. The Maastricht Treaty was signed. This was a busy, busy year. Okay, and then you had this remarkable upset in your election, where this John Major guy came out of no place and beat off Neil Kinnock, who was really a shoo-in, and your newspaper, The Sun, claimed that it's the Sun what won it. So we realized that we would need to do a study that enrolled older people without dementia who agreed to tell us all kinds of things about themselves and their lifestyles that could possibly be related to dementia. Do a detailed evaluation every year, donate blood every year, and as a condition of entry, everybody had to be an organ donor. Everybody had to sign an anatomical gift act. So they signed an informed consent. Later, they were required to sign a repository consent that allowed their data to be put in a repository and shared with people like yourselves. And then you don't get an autopsy consent. You can't consent to autopsy while you're alive. That's something you can only do after death. But what you can't consent to in the United States is an anatomical gift. At the time of your death, your brain becomes the property of your estate. And just like you can give away any other property of your estate, you can give away your brain. So it's an anatomical gift for the purpose of brain donation. And I'll focus mostly on the brain today, but be aware that we collect spinal cord, muscle, nerve, fat, bone, and other things. When you talk to old people, the number one thing they don't want to lose with age is loss of cognition. The number 2 thing they don't want to lose is the ability to get from here to there under their own power. All right, and so we do a lot of work on gait and physical function and disability. And then the last 2 things are they don't want to lose their vision and they don't want to be in pain. So we study those also. Okay, so here's kind of the model. Whoops. You have this brain. You have risk factors for Alzheimer's dementia. Those risk factors have to be doing something to the brain. So we're interested in risk factors for Alzheimer's dementia. We're interested in risk factors for what happens to the brain. And in some cases, we'll see that risk factors seemingly go to Alzheimer's dementia, and we're not at all sure what they're doing in here. So I'll just give you some sense of the scale of the studies now. Over the years, we've enrolled over 3,900 people from across the United States. One of these cohorts, the religious order study, is recruits across the United States, from California to New York, from northern Minnesota down to Louisiana and San Antonio. And we send teams out around the country to do all the testing locally. We draw the blood locally. The brains we've arranged for most of the sites to be taken out locally and then sent to us. There's a few sites in Illinois, in and around Chicago, including Wisconsin and Indiana, where we bring the bodies in and we do the autopsies ourselves. The other studies is in Cook and Neckar counties in northeast Illinois. Age 77 in enrollment, 3/4 women, about 7% African American, 2% Latinx. We've got about 2,100 autopsies, 1,300 spinal cord, muscle, and nerves. More recently, we've been taking the white cells from the blood that were cryopreserved while they were alive. And after they come to autopsy, we grow those white cells and we make them into induced pluripotent stem cells. We have about 110 lines right now, including 57 from African Americans. And so from there, we can induce those to become neurons and glia. So we can do studies in the dish of 100+ participants who we know their clinical, their pathologic, their molecular omic in their brain data, all right? And then we can see how we can manipulate specific individuals and how those relate all to one another. I think, a major step towards thinking about how to do precision medicine, incorporating what we know from the brain, but then get it back to somebody who's living. This just gives you the sense of the range of risk factors that we've published, a lot of genomic risk factors, a lot of experiential risk factors, psychological, medical. This is not all the data in the data set. There's a lot more data in the data set. We study a lot of other things. I mentioned physical function, which is really important to people, but we also study health and financial decision-making, health and financial literacy, susceptibility to scams. We study health and well-being, purpose in life, and things like that. And so basically, we study old people getting older. And then they die, we get their brains and other organs, and then we study them some more. All right, so this is what cognitive aging looks like. Not exactly what it looks like. It'd be a little bit squigglier if I gave you the raw data. This is a very good cognitive battery. It was 17 tests, it's now 19 tests. And to simplify it, I put it in a linear mixed model. And what we're interested is person-specific differences in slopes. Person-specific differences in slopes. We're not interested in differences between groups. We're interested in why are these individuals all different from each other? Why do these people decline rapidly? You can see they're very different ages, but they're declining rapidly. Some people declining slower, some people declining not at all, some showing some practice and learning effects. And then we're interested in what we get in the brain. And we can measure a lot of things in the brain. So this is a classic silver stain. It's actually a Bilshowski stain. It's a stain very similar to what Alzheimer would have used almost 120 years ago. Bilshowski was another neuropathologist at the time. This was a time in the 1890s, in the early part of the 1900s, where optics were being developed, ways of cutting the tissue were being developed, ways of staining the tissue. So there was a lot of progress in this area. And so it was relatively new, but like a lot of things in medicine and science, it becomes doable because technology catches up to things that you're trying to do. So this was modern technology. It just happens to be modern technology 120 years ago, 130 years ago. But we still use it. It works pretty well. This is a neuritic plaque. You see this splotch. This is a histological stain. It's not an immunostain. So I'm not looking at a beta or tau. I'm looking at a stain that just sticks to stuff. So it sticks to this stuff that's brownish, which we happen to know is beta amyloid. And then there's these dark tortuous neurites in here. We see some neurites in between, and then you see these neurofibrillary tangles here. So these are neurofibrillary tangles. Those are neuritic plaques, and then we have some what are called diffuse plaques. We have a little bit of neurites in them. And so we use these kinds of stains to define pathologic Alzheimer's disease, yes or no. Historically, we've used these. Now we also have to include in stain for A beta. Well, I'll come back to that in a second. So we can just count the density of these and the distribution of these plaques and tangles, their numbers, their distribution, and you end up with pathologic yes or no. We could also just count them all, count as many as we see, and then we can come up with an overall burden of the pathology in any particular region. We can do molecularly specific measures. So this is A betalosis. This is antibodies to amyloid beta. That's usually, and then we put this under a machine that measures the percent area of tissue occupied by amyloid. These are PHF tau, tangles, again, another immuno. We put that under a different machine, and it can give us the density. Okay, so here we're not getting density, we're doing something a little bit different. Here we get the actual density. This is amyloid angiopathy. This is the same amyloid, but in this case it's in the blood vessels. This was actually the first amyloid angiopathy, the first amyloid that was characterized back in 1984 by a group in Australia where they extracted the A beta and made the first antibodies. This is hippocampal sclerosis. And so basically the tissue is dead, the neurons are lost. You get this scarring in here. These are cortical Lewy bodies. They don't look like this. We put a little thing on them to make them red, make it easy to see. These are Lewy bodies you tend to see in the substantia nigra in Parkinson's disease, but in a lot of cases you see them up in the neocortex. This is a relatively new pathology, TDP43. It's a mislocated protein. It's a protein that is supposed to be in the nucleus that we find in the cytoplasm, and so it leaks out. It was first described in a paper in Science as a rare form of dementia in frontotemporal lobar dementia disease with ALS. And then we knew the investigator, we called him, sent us some antibody, and it turns out from this really super duper rare case, it turns out to be the second most common neurodegenerative finding that we have in the brain. And then we have vascular disease, atherosclerosis. This is the basilar artery, vertebrals, the basilar internal carotids. That yellow crunchy stuff is atherosclerosis. Arteriolar sclerosis, this is the thickening and dilating of the penetrating arteries. And this is an infarct, which is just a hole in the brain. There's a macroinfarct, which I can see when I cut the brain, just with my naked eye, and then a microinfarct is one where you can only see it under the microscope. They look the same, just one's really much smaller. In the brain, there's blood, there's brain, there's spinal fluid. And so if you have a hole in the brain from a lack of blood supply, you're going to kill that piece of brain. Eventually, the systems will come in, will clean it up, and that hole will be filled with spinal fluid. Okay, so we go now from pathologies, which we can only learn so much about, and now we get into the omics revolution. So we'd been preparing for this omics resolution from the beginning in 1994 when we first started collecting brains in these studies. We were freezing 1/4 of the brain. By 1997, we were freezing 1/2 of the brain. We were filling up one freezer after another. I was paying people to come in the middle of the night and put brains in freezers. I was putting alarm systems on freezers, getting called in the middle of the night that the freezer system broke and we had to come in and move all the brains. We had to build a system so we could catalog and find everything. And we waited and waited and waited and waited for the omic revolution that we knew would be coming, all right, but didn't really arrive until somewhere about 12 years ago. And before that, we were just filling up freezers. But since that time, the cost of the genome has come down markedly. You know, think about it. the Human Genome Project, which took place over the decade of the 1990s. That first genome cost $2 billion to make, and the first publication wasn't even complete. Now you can get your GWAS for $49 or $39 if you're doing a lot of people. Whoa. So the genome, but it's not just the genome. I can get that from your blood. It's better to get it from the brain for a variety of reasons, because there's things we can do with it from the brain. But then there's the epigenome, where things fell into place for us to be able to do various aspects of the epigenome, from DNA methylation to histone acetylation to ATAC-seq to different types of methylation. Now you can do genome-wide DNA methylation at a reasonable cost. Multiple types of transcriptomics. Bulk transcriptomics now is pretty straightforward. We just take a chunk of tissue and you digest it and you read off the RNA. But there's also single nucleus transcriptomics. There's spatial transcriptomics. There's a lot of ways to look at the transcriptome. And then there's a lot of things that are on the transcriptome that behave a little weird. So they're not just there to transcribe to a protein, but in some cases, some of these transcriptomes actually behave like epigenomes in the sense of turning the genes on and off. Eventually you get to the proteome and then the metabolome. And again, there's a lot of ways to do the proteome. There's your microRNAs, which feed back to your transcriptome. All this is happening in the context of your environment, and it's all leading to these ADRD traits, okay? And if you're really going to understand how you get from this to Alzheimer's dementia, you're going to need to deal with all of this. So here I'll put it in a more linear fashion. On the one end, we're collecting these risk factors: genomic, medical, psychological, experiential, environmental. At the end of the day, we want to prevent these syndromic traits, such as Alzheimer's dementia, for one. There's a number we'd like to prevent, okay? And then in between, we need to capture all of this stuff. So various epigenomics and epitranscriptomics, transcriptomics, proteomics, metabolomics. Everything on the right is mostly in the brain. Then we have our quantitative neurobiology, and that kind of then begins to mush into the omics, which is spatial transcriptomics, at the level of the cells, and the structural and functional MRI, antemortem, postmortem. These are we're getting from the blood, our cognitive testing, and our clinical diagnosis for cognitive impairment. As I mentioned, we also have spinal cord and muscle. We're also generating proteomics and metabolomics and RNA-seq. From there, we also have motor function. We have all kinds of data from biomedical devices. And then I mentioned some behavioral and neuroeconomic data as well. These are the most comprehensive, quantified, phenotyped human beings on the planet. And if you're interested in aging, we probably have the data. And then I mentioned we're generating iPSC lines, which we can then manipulate, turn into neurons and glia and manipulate and do various experiments on people based on things that we know about them when they were alive, or know about them from their clinical or their pathological or their omics or both, or all three. Okay, our data are sitting here in our resource sharing hub. We have more data. Here's good news for you. We have more data than we can ever publish in our lifetimes. My time horizons are shrinking. I'm hiring young people, so they got longer time horizons, but the data is exploding by design of the study. Every time we get another layer of data, there's almost an infinite number of ways to use it, okay? And I'm only showing you the data that's online. There are numerous layers of data being generated, okay? And the ways that we can capture data are changing. such that things can now be done that are, that we couldn't imagine before. The omic data is sitting in the AD Knowledge Portal. So if you go here looking for omic data, you will be sent here. Okay. If you go here looking for iPSC lines, you will need an agreement with us, and you will need an agreement with NICEF. The Agora is part of the Knowledge Portal, but it's basically the AMP-AD output of high interest targets. So if you're new to this kind of field and you're looking to see, what has the group of people working this space, not just me, but a whole bunch of people, think are valuable genes and proteins to interrogate, you can get those there. Okay, so far, I gave you just kind of a litany of what's there. All right, in the last few minutes, and I have a few minutes, okay, got the nod here from Sarah. Okay, I'm going to give you just a sampler of the kinds of things that could be done, just to kind of whet your appetite for what you might want to do, because I really don't know what. You've got all these tables, all these young people. I presume there's all these interests. I'd be very surprised if I said, are you interested in this? And everyone raised his or her hand. So just as a reminder, the study design, we enroll people without dementia. We document risk factors. They get tested every year. They get the full evaluation every year. Some of them get a number of sub-studies every year. Everyone's agreed to be organ donor. And then we get the brain. And so within a single study, we can look at risk factors for disease, risk factors for change in function. That has all the bells and whistles of a prospective analytic cohort study of risk factors for disease. Okay. Layered on top is the organ donation. And so what that allows us to do is within a single study, we can look at the biology of disease proximate to death, the biology of function proximate to death, the biology of function over multiple years prior to death. We can look at risk factors for pathology. And even though you get the pathology at the end, if you have a risk factor for loss of cognition, okay, the risk factor has to do something to the brain. The brain has to be the mediator. All right. And so with a little mental gymnastics, you can think about things that you measure in the brain as mediating the association between an exposure and at least a cognitive outcome. Gets a little bit more complicated, let's say, for a motor outcome where a lot of things happen outside the brain. All right, so let's start simple. You can look at risk factors for incident, MCI, and AD. Here's time is the metric. There's incident MCI, AD. This is purpose in life. There's a very simple analysis. I got tired of doing these hazard ratios because they gave me a headache and I wasn't sure what they really meant. And so we went to these accelerated failure time models. And here's one for depressive symptoms and neuroticism. And instead of looking at time, we actually fit these models across age, all right? And then we get average age at onset for, in this case, for depressive symptoms versus no depressive symptoms, about 5 years difference. For neuroticism, also about 5 years difference for high, that should be low neuroticism, not no depression. And so now we're looking at how many years you're getting as opposed to your hazard ratio, which does not easily translate into years. Okay, here is a surgical menopause. So the younger you are at surgical menopause, the more rapid your rate of cognitive decline. Surgical menopause, for those of you who don't know, is when you take out your ovaries before you've reached menopause. Surgical menopause is also related to neuritic plaques. It's one of the only things that we find that's not genetic that has a straight association with AD pathology. And then there's a hint that if you're on medication, to treat the symptoms than on estrogens, then you can slow this slope of decline. Here we're looking at the contribution of Alzheimer's disease to mortality in the United States. So with our studies of annual evaluation, we can capture incident disease pretty rapidly. Okay, most population studies that do this are testing every 4 to 6 years, and we're testing people every year. Right? It turns out that, let's say, over age 85, your time from onset to death is less than 3 years on average. All right, which is shorter than the average interval in most population-based studies. Right? From age 75 to 84, it's about 3.5 years. So it's still pretty short. So the time from onset of dementia to death is fairly rapid. Most people do not die at end-stage Alzheimer's disease. If you do an attributable risk model, okay, and you estimate the number of people who died from, I'm not going to make it causal, an attributable risk, meaning for those people that developed incident dementia, it contributes to their death. It contributes in a lot of different ways, just like a lot of chronic diseases. Think about all those pathologies. Each one contributes, all right? There is no single cause of dementia in those cases. You have multiple causes, and each one is contributing. Here, the number is about 500 people based on the 2010 census. So it's a very, very, very large number, much larger than you'd see at the CDC, for example. Here's the association of health and financial literacy with mortality. This is something cool that we were able to do. So there's been a lot of interest in secular trends of dementia, where people have been talking about dementia rates going down over generations. Here we were able to look at secular trends in pathology. So to look at secular trends in pathology, you're basically trying to get people that died about the same age, okay, but that were born in different birth epochs. So you're fixing the age, but you're allowing the birth epoch to shift. So we have people in the study that were born in the 1890s. We have people in the study that were born in the 1960s. Obviously, on those two tails, okay, I can't fix any of those ages and birth cohorts, so we got to chop those off. And even if when I chop those off, there's still a problem, and so we end up making birth epochs. We make 4, and then you standardize the data within each epoch, so you look at it across epochs. And what we see is across these epochs is moderate to severe atherosclerosis coming down quite significantly, moderate to severe arteriolar sclerosis, gross infarcts not doing very much, you know, a little bit going up as a matter of fact, which could be due to survival, improved survival in later epochs. And then if you look at the other pathologies, nothing for the global cognition, for global pathology, not much for amyloid. There's a hint that tangles might be going up a little bit. And then if you look at late and Lewy body disease, there's nothing happening. And so if there is any kind of uptick, we did see, I don't show it here, but we did see a slight improvement in cognition. It's probably a combination of the reduced vascular disease, you know, fighting off the slightly higher chronic microinfarcts. Microinfarcts don't do very much anyways. If you look at attributable risk of pathologies to Alzheimer's dementia, we get, here's demographics. This is if we add pathologic AD, if we add 7 other pathologies, and then a dummy variable for the unaccounted dementia cases, and we end up accounting for about 2/3 of dementia cases with these 8 pathologies. We can find people that have vascular cognitive impairment. We call it pure vascular cognitive impairment. I hate that word. It's not that pure. This means that their AD pathology is below the threshold for what's required for pathologic diagnosis. Doesn't mean they don't have no Alzheimer's pathology. I will say the Alzheimer's pathology doesn't contribute very much in these cases. But you do see a significant proportion of cases, and a much larger number than I would have expected, that have vascular cognitive impairment. We do a dietary questionnaire. So here we see a dietary questionnaire. There's a Mediterranean diet and the DASH diet. They're looking at relation to global AD pathology and A beta. So this is the MIND diet. This is a diet that's kind of a mush between the Mediterranean and the DASH. And this is the Mediterranean diet score. So it looks like it may be good for your pathology. I don't know what you're serving for lunch today, but if it's that meat stuff, you probably want to take it away. I think I saw some processed cookies. Yeah, no. All right, this is pretty cool. We have these early life cognitive enrichment measures. So early life socioeconomic status, age 12 cognitive reserve scores, and then age 6 and 8 and 12 cognitive activity, and then foreign language instruction at a young age. We make it into a composite. And here we can see the direct effect to cognitive decline from these early life factors with a significant, not big, but a significant portion that is basically mediated through AD pathology. Okay, so you can begin to now think about these pathology mediators along with, the direct effect after you account for the mediation. And here we did this also with neuroticism in the proteins. Cognitive reserve is basically where we regress out the effects of all the brain pathologies, and we're just looking at the residual cognitive slopes. And if you like imaging, these are some of our ex vivo imaging. So these are some markers of resilience that we generated from our omic data, first the genomic data, and then later the proteomic data. And this is showing that we can find the location in the brain by imaging of the footprint of some of these proteins. And I think one or two more. So this is a proteome-wide discovery that might provide motor resilience to pathology. So again, we regress out the effects of brain pathologies on motor function this time, and then you do a PWAS with that, and then we have what's called a Chicago plot. Yes, Chicago plot, it exists. Yes, I admit, I made it up. Okay, but, first of all, if you just go on Google and you take a look at the Manhattan skyline and the Chicago skyline, and just tell me which one's prettier, okay? I won't hold a grudge if you pick the wrong answer. There's no wrong answer. There's only one right answer. Okay, but what I like about it most is when I look at a Manhattan plot, I never know the direction of effect. So I see a p-value, but is that p-value good for you or bad for you? Okay, and we know some of those things are bad for you and others are good for you. So here, that's what you get here. You get a few proteins that are associated with greater resilience, and then proteins that are associated with less resilience. They're both equally interesting, all right, but how you would want to treat those would be the opposite. And then again, this is person-specific contributions of brain pathologies to progressive Parkinsonism. So these last two slides were backwards. I should have shown you this first, all right, to make you realize why we would want to do a similar thing that we do with cognition, and that's regress out the effect of pathologies on motor function, because a lot of those pathologies are related to motor function. Okay, so that's just a smattering of types of things you can do to see if I could capture your attention or imagination about something that you might want to do, in which case you go here to get our data. And then you go here if you want the omics. If you want cell lines, you got to start here and go there. If you want just omics, you can skip this. If you want a lot of granular metadata plus the omics, then you need both. And this is just to poke around and see what people find interesting. And I'm so happy I'm still awake. I've only managed once to fall asleep during a talk I was giving. That was in Helsinki, right after lunch as opposed to right before lunch. All right, so thank you very much. I'll be here all day. I won't be here all day tomorrow, but I'll be here all day today. So if anybody has any questions, please find me around. Thank you.
Thank you all the speakers very much. Very enjoyable, and I mean especially encouraging and inspiring from the talk that Professor David Bennett just gave us. I'm a psychiatrist myself, and also a dementia researcher working with wearable devices. I appreciate not only appreciate. I think many of your colleagues will really appreciate this Rush study, and I myself have read so many papers using the data from Rush study. Especially a few ones recently published using wearable device. For example, the ones published by Dr. Li Peng and I mean, of course you yourself as well. So what kind of recommendation you would probably give us these young researchers who may need to develop their own research in the near future with regard to those wearable devices? What kind of study design? Because I mean, probably not all the participants are willing to wear these devices, and some of the people's dementia stages may actually determine whether they are able to accept or not able to accept the devices. So what kind of recommendation would you give us?
Yeah, so we do a number of wearable devices. And because we're interested in getting that device, you know, when you're doing a study where a big portion of it comes after somebody dies, okay, when I think about the data I'm collecting, I don't think about what I'm going to collect the first year when I enroll somebody. Okay, I think about what am I going to be able to collect the last year before someone's dead. Okay, and so what that means is that you need to have a range of things that you do so you capture high functioning people, but that you're also able to continue to capture data as people become impaired. As I mentioned, not everyone becomes real impaired, but some people do, right? So our devices range from a device called Dynaport, which is a triaxial accelerometer and 3 gyroscopes. It's bigger than my watch, and you put it in the small of the back in a little pouch. All right, and when we test the people on site in their homes, okay, we ask them to do a variety of very standard epidemiologic in the house maneuvers, time up and go, a standard walk, etc. And that will get you triaxial, that will get you acceleration in every direction and angular acceleration in every direction. Okay, and you can get a lot of information from that. You could pair that with other things, which we have. You can pair that with the Microsoft Connect. You can pair that with a gate pad if you want to actually get more granular data. The other thing that we put on them is a actigraph, which goes on the wrist. Okay, and for this, we go to the home, we apply it. Okay, we pick it up, we check while we're there that the data are good. If the data aren't good, we reapply it. That data, we have them wear that device for 10 days. They can go in a shower, they can go through the airport, they can do whatever they want with it. And it's a physical activity monitor, except it's real easy to extract all kinds of other metrics from it. So you can get sleep, you can get circadian rhythms, you can get daily circadian stability, all right? You can get fractals, okay? I can't even explain to you what fractals are. I'm on 10 papers with them. I have 2 grants with it, but it gives me a terrible headache. Another device that we've used is a watch pat, which is a sleep device based on a figure plasmography, but you can still get sleep and sleep stages and sleep apnea. It's good for sleep apnea. It's not great for sleep stages. We're now piloting something called the ANI, which is a device that you wear on the small of your chest, all right? And it gets you an EKG, and it gets you speech, and it gets you heart rate, and it gets you temperature, it gets you a ridiculous amount of data. It gets you movement, all right? So this, if we can get this thing, we're working with, he's a dermatologist, biomedical engineer, okay? And he specializes in capturing data through the skin, all right? And so this is something that he developed with his own company. And so we're left with working out all the kinks. But once all the kinks are worked out, this will be a much better device than a lot of other stuff that we're doing. And this field is going to change. Okay, what people are going to be able to do with their smartphone and smart devices, you know, for inobtrusive assessments, which for some diseases like psychiatric diseases can be very, very, very useful. So I do think there's this is a space that's going to grow.
Thank you very much. Someone else had a question over here. Ulrich?
Hi, thanks very much for the amazing talks, all of you. I think fantastic survey of different approaches and techniques. I think I have one question for Dave, just picking up where he left, basically. I'm interested in sleep, so I have one of these interests.
It doesn't help to have the mic if you just
Sorry,
kind of hold
is
it
it
out
too
there.
far away? Okay. I have one question for you. I'm interested in
I have
sleep.
one answer for you, so you better ask the right question.
Okay. Ooh, let me think. Okay. Bit nervous now. Okay. Do you have any polysomnography data in any of your studies, as in sleep data that measures brain activity during sleep, as in any?
Sleep, you mean like EEG data?
Yes. Yeah.
We don't have EEG data. The ANI is not going to give us EEG data. We have sleep data.
So only from the watch pad and the actigraphy, or anything
The
else?
watch pad and the actigraphy. The watch pad, I mean, the watch pad's one night. The actigraphy is multiple nights. There's no recordings. We have looked at various recordings. You know, there are various, you know, simple surface things you can get. There's various nets you can put on people. I haven't seen any data to convince me, you know, there's only so much you can do with these people. And so is that the thing I want to do? There's only so much I can get my research assistants to do.
Yeah, I mean, you
Only
would
so much I can get my coordinators to do.
You'd have to
There's
get
no
them
end
into
to
a
what I
sleep
could
lab.
get funded. Okay, that's easy. Okay, but you still got to get it all done. Okay, and some of these things become an operational nightmare. So it's to get these things done. I mean, one of the nice things about the devices that we do is we package them into really cool givebacks for the participants. Now, some of them are givebacks that I have no idea what they mean, but they can make them into pretty pictures. But others, you know, people have found useful. So even with that WatchPad screener, we've identified people with sleep apnea that actually ended up on CPAP. All right. You know, so if are we to detect epileptic form activity from some of these simple? Probably not, because it's just not dense enough.
So you're not planning to use any wearables that would use brain activity like EEG or anything like a headband?
Yeah, you know, people have been doing EEG for a very, very long time.
Okay, thanks.
Okay.
Cheers.
Okay, thank you. So we have time for one more question, and I have a question for a couple of our panel members. Anyone else in the audience before we break for lunch? Okay, so I have a question for both ARUK and Alzheimer's Society. If someone wants to be an ECR representative at ARUK, who do they contact?
Probably me. It's probably your best bet. We have a research inbox, so you can get in touch with us about anything, any queries you have about grant eligibility, or if you want to be an ECR rep, you're more than welcome to drop us an email. If you come and see me, we've got little business cards with that email address on it for you. Thank you.
Great, thank you, Emma. And one last question, and this time it's for Alan. Alan, when you read the lay summary of grants and awards and scholarships, what is the most complex thing that ECRs struggle to get across in lay terms? So that difficulty where you read and reread it and you think, I still don't understand it. And any tips?
That's not an involved question, is it? I think the thing is, what people are looking for is lay people. We're looking to find out the core of the application, how the core of the application is being put forward, and then for us to think about it, because when you put forward those applications, they're only in the final paper submitted for the grant, they're only in 2 or 3 pages, whereas the scientific section may be 20 or 30 sort of pages. We're looking to understand what the outcome is going to be, how it's going to be shared at the end as well, because that's not necessarily the easiest thing for people for their dissemination and things like that. I know when I look at them, I'm a bit old-fashioned. I print them out and I get a highlighter pen and I use colours red and I use colours green. I thought it was just me, but I found out other people do the same thing. We're looking to understand that so that then we probably read them 2 or 3 times as well. And other people that are on the network that I speak to, they do the same. So getting that message over, using the glossary as well, and also understanding what's different, what's unique about it, what is going to help you really, that's going to put yourself in our position. What would I want to be looking at? What's going to motivate me? I must admit, being here today has motivated me even more than what I've been on. And I'd like to say thank you very much for the opportunity. Thank you for the question. Have I covered that all right, Cherie?
Brilliant. Thanks, Alan.
Okay.
Okay, I have one question for me. David, nice talk. Thank you. I noticed that you had very little diversity in those samples, and they were very old. Yeah, David, good pickup. So what are you doing to address diversity in age? In other words, specifically to get more people of color, African American, and to get more people with ethnicity? And the answer is, we're doing a lot. And if you come to my talk tomorrow at 9 o'clock, or 9:10, or whatever it is, it's on the schedule, you'll find out. Have lunch.
So firstly, I want to thank all the speakers. I think, I'm not biased, but I think it was an excellent lineup and good balance for you all. And I just want to thank you all for attending today and for coming to the ECR event, for submitting your posters. And I really hope you enjoy the rest of the conference. I think nearly all the speakers will be here for the next day or 2. What will be really helpful for us is if you just come in and tell us throughout the conference whether you liked the ECR event, have we really missed something out that you'd like to hear about next year? Because that's how we improve year on year. But thank you very much for attending, and I look forward to meeting you all. Thank you. Thank you.